Now in this video we'll be seeing how to configure the redistribution between two protocols. Like one side we have an RIP, other side we have EIGRP. Now how to do that? Now if you just get back to the basics what we learned, now we need to know that there are two things we need to keep in mind when we do redistribution. The router must be running both the protocols wherever we do redistribution, and we need to manually change the metric. So we discussed that in detail in my previous videos. So what we'll do is we'll take a small scenario where I got 3 routers. If you want to add more, you can add. So I'm going to assume that these routers are running RIP version 2 and the other part of the network is running EIGRP. Now by default, the first step I'm going to do is I'm going to do the basic advertisements, advertising the interfaces as per the diagram, advertising this in RIP on the left side and the right side is EIGRP. Now once you do these basic advertisements, what happens is the route 10 dot network here, you can see the 10 dot network. This 10 dot network will be advertised to router 2, but it will not get advertised to router 3. And the reason is because this side it is EIGRP and RIP updates will not be sent, will not be learned by EIGRP interfaces or EIGRP routers. Okay, so to fix that we need to do redistribution. So let's go ahead and first do the basic configuration. I'm going to start with router 1. On the router 1, advertising the interfaces in RIP, router RIP version 2, no auto summary, and advertising the LAN interface and WAN interface. If you want to add more interfaces, you can add. I don't need here. So similar way on the router 3, advertising both the interfaces, router EIGRP 100, sorry 100 it has to be, router EIGRP 100, and then I'm going to say no auto summary, network 30 dot network in the LAN and 2 dot network in the WAN. So router 1 is completely running RIP and the router 3 is completely running EIGRP, but we must have at least one router which is running both the protocols. That is mandatory because that router is responsible for exchanging the routes between two different routing protocols when we do redistribution. Again, it is not going to do automatically. We need to manually define the redistribution commands. So, but let's finish off with the basic configurations. I'm going to say router RIP version 2 and advertising RIP on the WAN interface on the left side. I think router 20 dot network is also in RIP. So let's do that. Now on the router 2, the 2 dot network belongs to EIGRP. So let's say router EIGRP 100, no auto summary, network 2 dot network. Now these are my simple redistribution labs. Now if you just verify, router 2 should be able to form the neighborship with router 3, you can see. And if I verify the routing table of the router 2, if I give show IP route, I can see, I should be able to see the routes coming from RIP, as well as I should be able to see the route coming from EIGRP. If you just try to observe on the router 2, the router 2 is able to receive this 10 dot network, and you can see here it's learning as RIP route, RIP, and it's learned via 1.1.1.1, and similar way it's also learning the route from EIGRP, it's 30 dot network, and you can see these all EIGRP metrics. But the thing is, router 1 will not be able to see the route 30 dot network. If I just give show IP route, you can see it's only learning the route from RIP, that is 20 dot network, but I'm not able to see the 30 dot network because the 30 dot network belongs to EIGRP, and by default router 1 will not learn any routes from EIGRP. Now same way if I check on the router 3 as well, if I give show IP route EIGRP or simply say show IP route, the router 3 is not learning any routes because the 2 dot network is directly connected and the 20 dot network belongs to RIP, but the router 3 is running EIGRP. Now I want to ensure that router 1 and 3 should exchange the routes, so I need to configure redistribution. Okay, so what I'm going to do is I'm going to do redistribution on router 2. So the first thing, the router must be running both the protocols. So in my scenario, router 2 is the one which is running both the protocols, which means I'm going to do redistribution on the router 2. So I do redistribution from RIP to EIGRP first, or it can be EIGRP to RIP. But again, we need to do mutual redistribution, both the sides. Let's start with EIGRP to RIP. Okay, so router 2, I need to go to router. Now whenever we do redistribution, we need to first get into the router mode, and router mode, it has to be, so we are redistributing from EIGRP into RIP. So I can say that this is my source protocol where I'm getting the routes, and I'm converting them into RIP. So my destination protocol will be RIP. So always when you do redistribution, we need to get into the destination protocol. So we need to say router RIP, see the direction, and then we need to say redistribute inside the router mode. And what is my source protocol? Source protocol is EIGRP. So I need to say EIGRP, and then you can use question marks, because when you use question mark, it will ask you the AS number. And then after that, we need to define the metric. As I said, whatever the metric used by EIGRP, it is cost. RIP cannot understand the cost. So RIP only understand hop counts. So we need to say metric, and then we need to define some metric in terms of hop counts. So which means I can give any number in between from 0 to 15. So let's say I'm giving a metric of 1 in terms of hop counts. So the metric has to be given in terms of hop counts. Mandatory. So let us configure this and verify on the router 2. So let's go to router 2, and on the router 2, I'm getting into my RIP protocol because that is my destination protocol. Redistributing EIGRP and use question mark. It is asking me the AS number. So I'm running EIGRP 100, and you can see, if you want, you can press enter, but if you press enter, it's not going to take automatic metric. So we need to compulsory define the metric. So I'm going to say metric as 1 hops. In terms of hops, you can use question mark. You can see the metric. I can use anything as 1. So now if I go to router 1, I should be able to see the route. If I give show IP route, I should be able to see the 30 network here, learned as RIP here. Now what happens here is router 3 is advertising 30 network as EIGRP update, and the router 2 will take this route as EIGRP, and then it's saying it's going to advertise them in RIP with a metric of 1. That is because we defined manually. That is something you have to do it manually, and then when it reaches here, it receives the 30 network with a hop count value of 1. So that's what you can see here. I'm receiving 30 network with a metric of 1. And there is no representation like normally you will see all your internal routes as R, external routes also will be displayed as R. So there is no differentiation in internal and external routes in outputs wise in RIP, but in EIGRP it will be different. In EIGRP, internal routes you will see as D, and external routes you will see as DEX. Anyway, once we configure the other way redistribution, we can see that. So let's go to router 3. And on the router 3, we'll verify whether I'm able to see the route coming from router 1, that is my 10 network. I'm not able to see, and the reason is we did only one-way redistribution. So we just did the redistribution of RIP, EIGRP into RIP. Now we need to do opposite side redistribution of opposite side from RIP into EIGRP. Okay, so again the source destination, the source protocol is RIP, and destination protocol is EIGRP. I need to go to router 2. I need to get into the router, which protocol mode? Router EIGRP 100, because that is my destination protocol. And then we need to tell redistribute. What is the source protocol here? RIP. We need to simply say space RIP, and there is nothing, just you need to use question mark. When you use question mark, you will find an option metric. Now here also, whatever the metric used by RIP, hop counts, EIGRP cannot understand, because EIGRP understand only the cost value, and that is something calculated based on the bandwidth, delay, load, MTU, and reliability. So which means we need to manually define the bandwidth, we need to manually define the delay, load, MTU, and reliability. 5 values we need to manually define, and based on the 5 values whatever you define, EIGRP will automatically calculate a separate cost based on the values for all the RIP learned routes. Now what happens if I don't define the metric? In EIGRP, if you don't define the metric, it takes a default metric of infinity, which means the routes will not get redistributed, and even though it's get redistributed, there won't be any metric. So there won't be any communication. So keep that in mind. Defining the metric in RIP and EIGRP is mandatory. You have to do that. Okay, so let's go to router 2 and verify the same in the command line. I'll go to router 2 and then we will do redistribution of RIP into EIGRP. So we need to get into EIGRP mode and then we say redistribute RIP, and then we need to define the metric. So metric, and then we can use question mark to find the next possible options. Bandwidth, any bandwidth you can give. Let's say I'm using 1000 kbps link. Now it's better to give the same metric values near to defaults. We can say near to defaults means assuming that it's my serial link and it's using some 1000 kbps of bandwidth, because the metric value will be calculated based on these values. Delay, so the default delay is 20,000, so I just go with the same values. Anyway, reliability, you can give any number because anyway they are not used in the metric calculation. So load is 1 and MTU is 1500. Done. So once we define these parameters, now router 3 should be able to see the route. If I give show IP route EIGRP, you can see router 3 is able to see the routes as DEX. Now the one difference you'll find here is the routes which are learned through direct EIGRP, you will see them as D, nothing but we call them as internal routes. And whenever we see DEX, you need to understand that these routes are learned from different protocol, maybe other than EIGRP, and they got redistributed into EIGRP. Now that's what you can see here, DEX. And one more difference is the administrative distance value will be 170. So for the normal learn routes, which are my internal routes, the administrative distance will be 90, and for the routes which are redistributed into EIGRP, it will be default 170. And the next value you can see here, this metric is calculated based on the bandwidth, delay, load, MTU, reliability, whatever we have defined at the time of redistribution. So based on those numbers, whatever you define, based on that, it's going to calculate and it's going to generate one cost for all the RIP learn routes. Okay, so this output wise a slight different, but this is how we do redistribution into RIP. So always we need to keep in mind, anything you do redistribution into BGP, the source can be any protocol. It can be RIP, EIGRP, it can be OSPF, it can be any other protocol. We need to mandatorily define the metric in terms of 5 values. And when you're redistributing any protocol into EIGRP, we need to manually define the metric in terms of hop counts. Anyway, we'll see how to do redistribution if you're using OSPF protocol probably in our next videos.